What's poppin', dogs? Mr. Allen here with some end behavior of different polynomial functions. Here we got a couple in standard form. Looks like we also have some factored form and something we might need to rearrange right here. All right, let's get popping. I personally, right, early on, I like to sketch a little graph of what I think this thing might look like. That really helps me with end behavior, okay? So I have a cubic function, right? That's the highest degree that takes precedent here. So it's positive. That means it's gonna look something like that. Right? It might not be that drastic. It could just be like a little kind of a thing like that. But in any event, what's happening on the left side is the function's going down, and on the right side, the function's going up. I can write my end behavior with that. So I'm going to have as x approaches negative infinity, f of x approaches, let's see here, as I go to the left, it's going down, so negative infinity. Beautiful. And as x approaches positive infinity, as I go to the right, these graphs are both going up. So f of x approaches positive infinity. Beautiful. Done. That's it. Awesome. All right. If you don't need the graph, feel free. You don't have to draw it, right? If you know, like, okay, I got an idea of what it looks like. I find that to be helpful, especially early on, and you're probably very early on in learning about end behavior right now. So I think the graph helps. This one here, let's see here. Highest degree is 4, right? We're not looking at the coefficient. We're looking at the degree, the exponent. All right, so this is a quartic function, a negative quartic function. So it's going to be like an M type of shape like this. It can also even, not really be that drastic. It can be like something like that right there. Okay, where it just kind of flattens out. But in any event, on the left and the right-hand sides is going down, yellow and timber. So I got as x approaches negative infinity, f of x approaches negative infinity. There we go. Hopefully we're not off the screen right there. Negative infinity. All right. And as x approaches positive infinity, f of x still, as we go to the right, it's still going down, yellow and timber. it approaches negative infinity as well. Cool. Awesome. Delightful. All right. Let's switch to blue. So this one here is not currently in standard form. You don't have to worry about rewriting it in standard form. You know this is going to be, let's see here, a cubic. That's the highest degree there. It's negative, so we know it's going to be a negative cubic. But if you'd like to rewrite h of x in standard form, it's not a bad move. A lot of times we might ask you to even just do that anyway. So I'm going to go ahead and do that because I've already done it. I'm done. Just talking about it, I got it done while talking about it. All right, so we have a negative cubic, so that means it's going to look probably something like this, right? Or, as we said, it might, maybe be a little more drastic. Who knows? I do not care, though, because all I care is what's happening on the left is going up. What's happening on the right is going down. Let's write our end behavior. As x approaches negative infinity, f of x approaches. As we go to the left, it goes up. So it's important to think about how these things read, right, with normal words. As we go to the left, my graph is going up. As we go to the right side of the graph, my graph is going down, which would be negative infinity. This is the formal way of notating it, but that's how it would read, or if you were to say that in just like normal words, okay? Not be so hoity-toity fancy math person about it, right? All righty, last one here. Last one. Oh, boy. I don't want to write this in standard form. That'd be a huge pain, way too much work. But, this will eventually give me x cubed, right? Because that's going to be cubed. If I were to multiply it out, x minus 3, x minus 3, x minus 3, and then the x plus 1. Overall, I'm going to have something x to the fourth and a bunch of stuff thereafter. I don't care about that stuff. All I care is that it's a positive quartic function. Therefore, it's going to look something like this, right? It could look maybe, it's going to kind of pass through this one and kind of bend, but whatever. It's pointing up on both sides. That's all I care about with end behavior. And that's all we're talking about in this video. And we'll ask a question like that, maybe multiple choice for response. What is the end behavior? Okay. So here we got as x approaches negative infinity. As we go to the left, f of x approaches positive infinity. And one thing before I forget, if this is written out for you, double check that they started with negative infinity. Some books, some questions, SAT, whatever it may be, say as x approaches infinity first. You need to be very diligent and careful and make sure that you answer the question or fill in the blank properly, okay? If you get to choose, I personally like to go with the negative infinity first. It makes sense. I talk about the left, I talk about the right, I'm done. You know what I mean? You know what I mean. As x approaches positive infinity, f of x is also going to be approaching positive infinity as it's going up on both sides of the graph. One last thing I want to touch on here is that if you look at your even degrees, the end behavior is the same for both, meaning both of these were negative infinity. Both of these were positive infinity. And for my odd degrees, my cubics, both of them happen to be cubics, but it would be the same for linear, the same for quintic, degree of 5, right? The end behaviors are different. One is going to negative infinity, one's going to positive. One's going to positive, one's going to negative. That is always going to happen. So if you end up getting the same thing for an odd degree function, perhaps you screwed up on one of them and you can go back, double check that stuff, check yourself before you wreck yourself. That's it on this one. End behavior, it's dope. It ain't going anywhere. And I hope you guys aren't going anywhere either. Hit that like, hit that subscribe, YouTube stuff. Peace out.